Hello and welcome to our virtual Lunch and Learn. Today we're talking about SwiftE 3D sensors. My name is Rachel Green and I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. Presenting for us today will be Corey Lumadou, Integration Engineer out of our Ann Arbor, Michigan location. And out in the comment section, ready to answer your questions, is Mike Brennan, Systems Engineering Supervisor out of our Madison Heights, Michigan location. We also have a Q&A portion at the end for Corey to answer your questions in depth. Hi, Tom, Carol, and Jim. Thanks for joining us today. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us. If you come in, let us know where you're tuning in from in the comment section. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist. And we cover a new topic every Wednesday at noon, so be sure to join us on your lunch break going forward. Hi, Andy and Derek. Thanks for joining. We'll be looking for questions as you have them in the comments, while our presenter, Corey Lumadou, gives an in-depth overview of the SwiftE 3D sensor and the use of time-of-flight technology over an area with multiple points. Our specialist, Mike Brennan, is ready to respond to your questions in the comments as we go along, and we'll have a Q&A segment at the end of Corey's presentation. If you'd like to reach out afterwards or if you have further questions for Corey, you can always send us an email at mcmclive@mc-mc.com. Be sure to let us know which session you attended and we'll direct your questions to Corey. We'll have that email address on the screen for you at the end of the presentation as well. It looks like we have a number of attendees now, so let's get started. Corey, I'll pass it over to you.
All right, can you hear me?
I can.
All right, thanks, Rachel. So yeah, today we're going to go over the SwiftE 3D sensor from Rockwell. We'll start by looking at the time-of-flight technology and go through the SwiftE technical information, software programming capabilities, go through a few demonstrations, and then talk about applications. So the technology behind SwiftE is time-of-flight, also known for its abbreviation TOF or TOF. Basic definition of time-of-flight is simply a measurement of time taken by an object to travel through a medium. The SwiftE uses pulse light along with light frequency, and measures the time taken for each transmitted pulse to reach an object and then return to its receiver. From there, we can calculate the distance. Time-of-flight's not new to Rockwell. This is the 45 DMS, distance measurement sensor. It's a single-point time-of-flight sensor, primarily used for long-range presence, absence, and distance applications. So SwiftE is really just expanding on that technology. Now, instead of a single laser point, SwiftE has over 300,000 individual points of light within the 640 by 480 pixel field of view. Each of these points can be considered a separate sensor within that field of view. So a simple way of thinking about this is comparing to a 3D pin toy. Each individual pin is just like each individual pixel of light. SwiftE compiles all these data points into a point cloud, and from there it creates a color map based on blue for far and red for near. So this is how it works in a real-life application. Starting from the bottom with the actual image of packaged meat, the sensor is evaluating everything in that field of view. From there, the user-defined virtual sensing zones are applied. When you create a virtual sensing zone or a VSZ, the sensor will calculate the average measurement of all the pixels it contains. Once you've created all those VSZs needed in the application, the pass-fail parameters would be set in the PLC. So where it fits, SwiftE fits somewhere between traditional sensors and vision systems. Based on the configurability and Ethernet IP protocol, it's much more intelligent than standard sensors. Can also solve applications where multiple sensors would have been used in the past versus just a single unit. When you compare to the vision systems, SwiftE is set apart due to the fact it's not evaluating or comparing actual images. Instead, it's just distance values. So again, based on the configurability and Ethernet communication, it belongs in Rockwell's family of smart sensing. As shown here in the diagram, the Ethernet protocol allows SwiftE to be included in the overall connected enterprise. Technical information. Some of the key points hit on here. Again, the 640 by 480, it gives us over 300,000 individual points. Measurement resolution of 1 centimeter. Operating range 0.5 meter to 6 meter. It's going to output height or distance values. And again, the Ethernet IP protocol. You've got up to 64 individual sensing zones can be applied to each template. And the sensor can hold up to 255 templates. The footprint of the sensor is about 5.5 by 3.5 inches. This slide explains the field of view, how that's calculated. So it's based on the distance the sensor is mounted from the target. So the X direction would be 80% of that, the Y being 60%. So with a 2 meter distance, I'm going to get a 1.6 by 1.2 meter field of view. Part numbers and accessories. So you have the option of ordering this with or without rubber protective end caps. And you've got a couple different power supply options, bracket, and cables. Programming and software. So it comes with free web interface. Just a static IP address, optional password, and then the sensor comes pre-calibrated in centimeters. This is an example of a complete system setup. So starting with the browser, then over to the sensor through Ethernet IP to the controller, and then to your HMI. And currently requires version 20 or later of Studio 5000. This is what it looks like going into the Studio 5000. There's no need to actually download the AOP. Once it shows up in RS Links, just right-click and upload the EDS files. And as long as the correct template's in output assembly, then it will communicate back to the HMI application. So here's some examples of HMI applications created by Rockwell, but you also have the option of creating your own. Demonstration. So, and this is the web interface. Already have the IP address entered. This is not protected, so just a login. And now I've got a range view showing that color mapping. I click over to intensity, it's going to show just a raw infrared image. Then we can actually adjust that color mapping. This has nothing to do with the measurement, it's strictly user preference. And you have the option of creating new or select from existing, create new here. Here's your parameters. So just lighting, that black is oversaturation, so we don't want to see much of that. The next parameters, we have threshold, that's just where the light starts to read in the sensor. Filtering is to smooth out the image, but you do sacrifice your time. So we're going to start with some square virtual sensing zones. This is a nice feature, you can copy paste, and then align and distribute to get even spacing. And we'll just copy and paste that for the second row. And just like that, we have 6 individual sensors activate. Now you have a distance from the sensor to the target. If you want to see actual height, you need to train a background. It will deactivate, click over to height, apply the background, and now we should see zeros on each of those boxes. Now when we put the soup box back in place, that is the actual measurement or height of that box in centimeters. Back to averaging. If I move a box halfway between 0 and the 12, then obviously I should end up in the middle. So that's it. Simple as that. We've got now 6 individual sensors with data being output through Ethernet IP. This application, you see both the HMI application and the template. So we have 11 different zones set up here. This could represent like a conveyor or a pallet. And when you watch a hand move through here, you'll see correspondingly the measurements adjust at the same time. To the left, light bar is currently set to 50. This is also where you can set your parameters for pass fail. You can also change it from a continuous monitor to an individual triggering device. This is a really cool application. This is for fullness, percent of fullness. So think of like bulk storage, dunnage, silo hopper. So we're going to do one single sensing zone. So again, remember how the averaging works. Start off by using a segmenting tool so that we can just connect dots to the exact size and shape we want. Train the background. We'll put a lid over the top to show what overfull value is. Ends up being 27, so we're going to adjust the fullness to 25. Now when we put objects into the box, it's going to show us that percentage of fullness. And again, keep in mind that averaging over an area, vertical or horizontal, it's the same. Orientation doesn't matter. Continue to add. So again, very good for overall level area detection. A lot of times when you are looking at level for dunnage or storage, you don't know where that peak value might be. So with this, you could also take and put multiple sensing zones around to determine where that highest point is. So palletizing application is a perfect fit for the Swifty. You see the 3 different layers. First layer, multiple sensing zones all across that surface to ensure there's nothing there to affect the integrity of the stack. Then each layer after that has known points and heights. So if any one of those is out of line, I get an alarm output here. So now here we have really small, precise sensing zones around the corner. So this would be for stack integrity. So if either the pallet or the parts are out of angle at all, as shown over here, we get again, alarm outputs. Additional applications, packaging and kitting and assembly. In the level applications, food and beverage, palletization, depalletization, part ejection in plastics, flashing detection. You can actually put real tiny individual zones all around the parameter and pick up any flashing. Web and edge monitoring, again, you can be very precise. And then AGV, guidance, mapping, and collision avoidance. Any additional information on this can be found at Rockwell or otosimaging.com. And the rest is left for questions.
All right, we do not have any questions at this time, but we'll give just a few moments here for anyone that does have some follow-up questions. Corey, feel free to add your questions to the comment section and I will read them out. While we wait to see if we do have any follow-up questions, I'd just like to remind you that you can watch the recordings of previous virtual lunch and learns on our YouTube channel at any time. And if you're watching this as a recording and have questions for Corey, don't hesitate to reach out at that email address on your screen, mcmclive@mc-nc.com. All right, it does not look like we have any questions at this time, so I want to thank Corey for this wonderful presentation today. Thank you, Mike, for being a resource out in the comments section. We hope the session was informative and engaging for you. Thank you to everyone for joining us here today. Remember to subscribe to the McNaughton-McKay YouTube channel for more industry content, and we look forward to seeing you live again soon. Thank you, everyone, and have a great day.